Hello everyone. Today we will going to see some practice questions from the topic atomic structure. And this is our part 1. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So today we will going to see some practice questions from question number 1st to question number 9th. Let's start with the question number 1. The radii of an atom and atomic nucleus is of the order of. So for the we have to find out the order for the radius of an atom and for the radius of an atomic nucleus. Options are 10 to the power minus 12 meter and 10 to the power minus 10 meter, 10 to the power minus 10 centimeter and 10 to the power minus 8 centimeter, 10 to the power minus 10 meter and 10 to the power minus 15 meter, or 10 to the power minus 15 meter and 10 to the power minus 10 meter. So you have 10 seconds to solve this question. After that, we will see what is the answer. Okay, so let's see. So it has a correct answer of option C. And the radius of an atom and atomic nucleus is in the order of 10 to the power minus 10 meter and 10 to the power minus 15 meter. So these are the correct orders for the radius of an atom and the nucleus of an atom. Okay, and thus our option C having these value is the correct one. Okay, let's move to next question, question number 2. Atom consists of electrons, protons and neutrons. If the mass attributed to neutron is halved and that attributed to electrons is doubled, the atomic mass of carbon atom would be approximately. Carbon atom having 12 atomic mass and 6 atomic number. But we just change the mass of neutron to the half and the electron to the doubled. Okay, then what will happen? So what will be the atomic mass of carbon then? Options are same, doubled, halved, reduced by 25. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. So the correct option is option D. No change by doubling mass of electron. So if we double the mass of electron, no change will happen. However, by reducing the mass of neutron to half, if we reduce the mass of neutron to half, the total atomic mass becomes 6 plus 3 instead of 6 plus 6. So as you know that the atomic mass of an atom is calculated in terms of proton plus neutrons, and if we reduce the mass of neutrons to half, so the number of neutrons is decreased to 3 from 6, right? So the total atomic mass will be counted by 6 plus 3, not by the sum of 6 plus 6. So the new atomic mass after reducing to half the mass of neutron, the new atomic mass will be 9 by 12 because 6 plus 3 is 9 divided by total mass which is 12 into 100. So it is 75%. So it should be 100%, but it is reduced to 75%. So what is the reduction in the atomic mass? In the percentage, it is 25%. 100 minus 75, 25%. Right? So that's why option D is the correct answer. Okay, let's move to question number 3rd. Many elements have non-integral atomic masses because, so it is observed that many elements have non-integral means not a integer value, have their atomic masses in non-integral value. So what is the reason behind it? You have to select from the options. Options are Their isotopes have same number of neutrons. Their isotopes have non-integral masses. They exist as isotopes. Their constituents, neutrons, protons, and electrons, combine to give fractional masses. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see what will be the answer. So the correct answer is option C. So many elements have their several isotopes, right? So many elements exist in the isotopic form also. So for such elements, the atomic mass is average of atomic masses of different isotopes. So if let's suppose X is any element and it has several isotopes like X1, X2, X3, right? So if we want to find out the atomic mass of X, we just take the average of atomic masses of all the isotopes, that is X1 and X2 and X3, right? And whatever the average atomic mass will come, that will be the atomic mass of the element X. So we just calculate the atomic mass of elements which is having several isotopes in this manner, and the average of the atomic mass when we calculate it is usually in known, it is usually known integral. And so the for the reason that many elements have non-integral atomic masses, why this is the correct explanation, and thus option C is the correct one. Moving to question number 4. Rutherford's alpha particle scattering experiment eventually concluded that. So, what is the conclusion of Rutherford's alpha particle scattering experiment? We have to select from the option. Options are mass and energy are related, neutrons are buried deep in the nucleus, electrons occupy space around the nucleus, the point of impact with matter can be precisely determined. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see what will be the answer. So correct answer is option C. Since majority of alpha particles penetrated the metal foil undeflected, Rutherford proposed that most of the atoms must be empty spaces occupied by lightweight electrons. Right? So this is the conclusion of Rutherford's alpha particle scattering experiment, and thus our option C is the correct statement. Okay, moving on to next question. Question number 5. A photon of light of wavelength 6000 angstrom has energy E. What will be the wavelength of photon of a light which has energy of photon 4E? Initially, we have a photon who has a wavelength of 6000 angstrom and has energy of E. We have to find out the wavelength of photon who has energy of 4E. Options are 1500 angstrom, 6000 angstrom, 2000 angstrom, or 750 angstrom. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so let's see. So the correct answer is option A. Uh, you know that E, that is energy, is equals to hc by lambda, or you can say that energy is inversely related to the lambda. Now, as for photon 1, we have given the wavelength, which is 6000 angstrom. So energy, that is E1, for the first photon is inversely related to 6000, because 6000 is the wavelength of that photon, of that light, right? Now E2 will also be inversely related to lambda 2, right? That is their second photon wavelength. Now if we write the ratio of E1 and E2, so E1 divided by E2 will be lambda 2 divided by 6000. And you know that E1 is given as E in the question here, and E2 is given as 4E. So E by 4E is equals to lambda 2 by 6000, and you can cancel out the E. it will be lambda 2 is equals to 1500 angstrom, right? And we have calculated the wavelength for the second photon, and thus our option A is the correct answer. Okay, moving on to question number 6. Calculate the wavelength of a helium atom whose speed is equal to root mean square speed at 293 Kelvin. And we have given the formula of root mean square speed, which is equals to under root 3 RT divided by M. R is gas constant, T is temperature, M is molar mass. And we have to find out the wavelength of helium atom whose speed is given, which is equals to root mean square speed, and root mean square speed is equals to under root 3 RT by M. Options are 6.51 into 10 to the power minus 5 nanometer, 7.38 into 10 to the power minus 5 nanometer, 7.96 into 10 to the power minus 5 nanometer, or none of these. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see what is the answer. So the correct answer is option B. So we know that mass, if we calculate the mass of one helium atom, okay, so if we calculate the mass of one helium atom, it will be total mass divided by the number of atoms. It is total mass is 4 for helium divided by the number of atoms, that is N naught, that's Avogadro's number, 6.02 into 10 to the power 23. Now we have given that the speed is equals to the root mean square speed, which is 3 under root 3 RT by M. Let's put the value 3 multiplied by R. R is 8.3143 into temperature, which is 293 Kelvin, divided by M, and M is 4 into 10 to the power minus 3 meter square per second square. Now on solving this, we have V is equals to 1351.69 meter per second. So speed is this much. Now we have to find out the wavelength. So wavelength formula is will be equal to h upon mv. H is Planck's constant, which is having a value of 6.626 into 10 to the power minus 34, and divided by m. M is this, we have calculated, 4 upon 6.02 into 10 to the power 23, multiply by v. We have v, that is velocity, which is speed, which is we have already calculated, and 1351.69. And on solving this whole fraction, we have lambda or wavelength is equals to 7.38 into 10 to the power minus 5 nanometer. So this is our final wavelength which we have to calculate, and thus our option B is the correct answer. Okay, let's move to question number 7. The work function phi of some metals is listed below. You can see here in the diagram, in the table, the number of metals which will show photoelectric effect when light of 300 nanometer wavelength falls on the metal is. So in this table, we can see that we have metal on first column, and its work function in electron volt in the second column. So we have their values respectively for like lithium, sodium, potassium, magnesium. Now what we have to do, we have to find out the total number of metal atoms which show the photoelectric effect when the 300 nanometer wavelength of light cross or falls on the metal surface. So which metal show photoelectric effect? Options are 2, 4, 6, 8. You have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, let's see. It has a correct option of B. Uh, as you know that energy of photon is equals to hc by lambda joule. And if we want to write it in electron volt, we just divide it by E. So hc by E lambda electron volt. Now let's put the value h for Planck's constant. It is equals to 6.626 into 10 to the power minus 34 into c speed of light, which is 3 into 10 to the power 8, and divided by E. E is 1.602 into 10 to the power minus 19, and lambda is given as 300 nanometer, which is in meters, 300 into 10 to the power minus 9. Now on solving this fraction, we have energy of photon is equals to 4.14 electron. Okay, so work function or energy of photon we just calculated. So for the photoelectric effect to occur, energy of incident photons must be greater than the work function of the matter. So the energy or the light which is falling on the surface of the metal, their photons should have the work function. Their photons should have the energy greater than the work function of metal. Okay, and for every metal the work function is for every metal their work function is having some value. So the energy for the incident photon should be greater than the work function of the metal. So we just check in the list in the table that whose work function comes in that category. So hence only lithium, sodium, potassium and magnesium have work function less than 4.14 electron volt, and because their work function is less than this energy of incident wavelength of incident photons, that's why only these elements will show the photoelectric effect. So how many are these? These are 1, 2, 3 and 4, and that's why the correct option is option B, that is 4. Okay, let's move to next question. Question number 8. A 25-watt bulb emits monochromatic yellow light of wavelength 0.57 micrometer. What will be the rate of emission of quanta per second? So we have to find out the rate of emission of quanta per second. And we have a 25-watt bulb which is emitting monochromatic yellow light of wavelength 0.57 micrometer. Options are 7.17 into 10 to the power 19, 0.717 into 10 to the power minus 19, 71.7 into 10 to the power 19, or 7.17 into 10 to the power minus 19. So you have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, let's see. So it has a correct answer of option A. So as we just see that energy of photon is equals to hc by lambda. H is Planck's constant, which is equals to 6.626 into 10 to the power minus 34. C is the speed of light, which is 3 into 10 to the power 8, divided by lambda, that is a wavelength, and wavelength we have given 0.57 micrometer. Converted it into meter, 0.57 into 10 to the power minus 6. On solving this fraction, we have energy of photon is equals to 34.86 into 10 to the power minus 20 joule. Now we have watt, which is equals to power. So what is a 25-watt bulb we have given mentioned in the question, right? So watt means power, and power is equals to number of photons emitted per second into energy of photon. So we have given power as 25 watt. So 25 is equals to number of photons emitted per second into energy of photon, which is we just calculated. So 34.86 into 10 to the power minus 20. Now we can calculate this term, this unknown term here. That is number of photons emitted per second. It will be 25 divided by this energy of photon. And after calculating, it is coming out as 7.17 into 10 to the power 19%. So this is the number of photons emitted per second or rate of emission of quanta per second. Okay, and thus our option A is the correct answer. Okay, moving to question number 9. The critical wavelength for producing the photoelectric effect in tungsten metal is 2600 angstrom. What wavelength would be necessary to produce photoelectrons from tungsten having twice the kinetic energy of those produced at 2200 angstrom? Now, options are 1800 angstrom, 1907 angstrom, 1926 angstrom, or 215 angstrom. 2015 angstrom. You have 10 seconds to solve this question. After that, we will see what will be the answer. Okay, let's see. So it has a correct answer of option B. Critical wavelength corresponds to work function. Now, work function is given by HV naught is equals to Hc by lambda naught. Also, kinetic energy at lambda 1 is equals to twice of kinetic energy at 2200 angstrom wavelength. And it is mentioned in the question, right? So we just write the kinetic energy at lambda 1, which is Hc upon lambda 1 minus Hc upon lambda naught, is equals to twice of Hc upon lambda 2 minus Hc upon lambda naught. Let's put the values. Lambda naught will be 2600 because initial wavelength is given, and it is equals to twice of lambda 2, which is 2200, minus lambda naught, which is 2600. Hc just cancelled out because it is present in both left hand side and right hand side. Now let's equate this equation. It is 1 upon lambda 1 equals to 1 upon 1100 minus 1 upon 2600, and on taking LCM, we have 1 upon lambda 1 is equals to 1500 divided by 1100 into 2600. So lambda 1 is equals to 2600 into 11 divided by 15, and it is coming out as 1907 angstrom. And thus our correct option is option number B. Okay, thank you.